Evet arkadaşlar merhaba. Hepinize iyi günler diliyorum. Hoş geldiniz kanala. Çalışmama hoş geldiniz. Benim ismim Hasan Zeki Alp. Beni tanıyorsunuz. Sevgili arkadaşlar epey zamandan beri bilimsel Python modülü olan, kitaplığı olan SciPy'nin ismini sıkça duyuyorsunuz şu sıralarda. Elbette bilen biliyor. SciPy'ın Scientific Python adı altında bilimsel işlemlerde, bilimsel hesaplamalarda kullanabileceğimiz bir Python modülü olduğunu, hatta bununla ilgili de diyebilirim ki ben şimdiye kadar bir takım dersler hazırladım. Ancak şöyle söyleyeyim, bunun aslında Pure Python'ın çok ötesinde, hani bilimsel olaraktan, affedersiniz, evet, aslında bu da faydası oluyor mu bu kapsül mikrofonun bilmiyorum ama bilimsel Python modül olaraktan bunu zaten biliyorsunuz, haberdarsınız. Mühendislik matematiği kapsamında da işlemlerin birçoğunu aslında burada Scientific Python'da anlatılan metotların, klasların, yöntemlerin, algoritmaların sayesinde çözüyoruz ya da işte bunun vasıtasıyla daha kolay bir şekilde çözüme ulaşıyoruz. Ancak benim yaklaşımım şu: acaba kaynaklarımızda, daha önceden yağlandığımız kaynaklarımızda içerik bakımından yenilikler var mı? Yeni API'ler var mı? Veyahut da doğrudan doğruya bu konuda başka böyle dört başı mamur kurs var mı? Bir materyal var mı? Bunun arayışı içerisindeyim. Eğer bulduğumda da veyahut da bununla ilgili özel böyle spesifik algoritmalar, örneklerde bulduğumuzda bunları sizlerle paylaşıyorum, Türkçeleştiriyorum. Aslında sevgili arkadaşlar, bir anket, bir topluluk ankete, bir polling uyguluyorum size. Bugün belki de işte kanalı incelerken görmüşsünüzdür. Kimi bilimsel kitaplıkları, Python kitaplıklarını orijinal İngilizce lisanında sizlere anlatayım mı? Bunu da nereden çıktı hocam diyebilirsiniz. Bir kere terminolojiye veyahut da işte oradaki metotların, orijinal işte fonksiyonların, klasların adlarına orijinal haliyle aşina olup hem de biraz da İngilizcenize katkıda bulunmak bakımından. Tabii öyle çok ağdalı bir İngilizce kullanmayacağım. Eğer o uygulamada, o oylamada pozitif bir cevap çıkarsa, dolayısıyla da hem muhtemelen bu dersi İngilizce olaraktan alan, yani bu Python dersini İngilizce olaraktan alan arkadaşlar için zor olmayacaktır ama bir taraftan da en azından artık ola ki bir uluslararası ortamda çalışma fırsatı da bulduğunuzda intibakınız çok kolaylaşacaktır arkadaşlar. Benim amacım o, yani o maksatla. Bununla ilgili bir oylama var. Eğer ki işte %50'nin ya da işte %30, %40'ın üzerinde İngilizce bir deneyelim hocam diyerekten de çıkarsa, bu dersleri size olabildiğince böyle sade İngilizcemle, kırık dökük İngilizcemle anlatmaya çalışacağım sevgili arkadaşlar. Peki şimdi hemen paylaşım ekranına gelelim ve de ne yapıyoruz, ne ediyoruz, nerede neyi gösterdik sizlere, onu da göstermek istiyorum. Şimdi aslında serinin başka kitapları, başka web siteleri de var. Ancak bunları incelediğimde kimisinin çok yüzeysel geçtiğini, kimisinin çok ayrıntıya girdiğini ve de bu ayrıntı içerisinde konuyla ilgili olmayan kişileri de böyle iyice bezdirip kaçırttığı web siteleri var. Ama şimdi tabi sadece basitle de ilgilenmek olmaz. Şeytan ayrıntıda gezilir misali. Neticede en küçük ayrıntının ya da işte en küçük bilimsel API'nin bile pek çok zor işlemleri kolaylaştırdığını biliyoruz biz arkadaşlar. Yani bir komutla, iki komutla, küçücük birkaç satır komutla yani bir takım çalışmasıyla yapılabilecek olan istatistiksel işlemleri biz yaptırabiliyoruz. Konumuz SciPy, yani Scientific Python, bilimsel Python. Başka bir deyişle veri biliminde ihtiyaç duyduğumuz algoritmalar, metotlar, aritmetik çözümlemeler, lineer denklem takımı sistemi çözümlemeleri ya da işte daha ileri gidersek karmaşık fonksiyonlar, kompleks düzlem üzerinde işlemler ya da işte 3 boyutlu denklem veya da ortam çözümlemeleri, her şey bunun içerisine giriyor. Elbette burada bütün ayrıntılarıyla hani bir derste, iki derste veya da işte birkaç serilik bir derste bu devasa okyanus gibi okyanus derinliğinde bu bilgileri aktarabilmenin imkanı yok. Ancak konu başlıklarını ve birer örneklerle sizlere yetineceğim. Bu derste sizlere bu w3schools.com diyerekten ben bunu W3 Üniversitesi diyorum arkadaşlar. Başından itibaren pek çok kursu buradan yararlanarak sizlere anlattım. SciPy'ın da aslında çok bir saniye arkadaşlar. Zil çalıyor. Evet arkadaşlar, şimdi diyeceksiniz hocam aslında oynatma listelerinde SciPy'ın dersleri var. Sevgili arkadaşlar, her seferinde yenilik var mı diyerekten bakıyorum. Üstelik de yeni bir URL'den de olabildiği kadar sizlere farklı kaynaklardan anlatmaya çalışıyorum. Scientific Python'ın ne işe yaradığı konusunda da şöyle söyleyebiliriz. Veri biriminde yani data science söz konusu olduğunda belli başlı işte amiral gemisi Python'ın NumPy modülü var. Görselleştirme ile ilgili modülleri var. Ve de verinin işte ön hazırlığıyla ilgili modüller var. Bir de asıl işte makine öğrenmesi ya da işte derin öğrenme ya da işte yapay zeka ile ilgili modellerin oluşturulması esnasında hemen bizim işte 2 satırda işimizi görebilecek modüller var. Bunlardan bir tanesi de SciPy. Dolayısıyla böyle işte çok karmaşık ekip çalışmasıyla veyahut da böyle çok işte sayfalarca sürecek bir analiz sonucunda işlemleri biz makineye yaptırmak istiyorsak bunlarla ilgili API'lar yani API dediğimiz bu hazır program arayüzlerinden yararlanıyoruz sevgili arkadaşlar. Şimdi sizlere de w3schools.com adlı web sitesinin hemen şu URL'de de sizlere paylaşayım her zaman olduğu gibi. Bunun içerisinde işte kaynak URL'imiz şurası. Şöyle diyebilirsiniz, hocam biz bunun kursunu gördük daha önceden. Evet var ancak bu yeni seride hem de başka bir katkılarım da olacak sevgili arkadaşlar. Tabii tekamüle inanıyoruz ve de her seferinde bir konunun üzerinden ikinci bir kez veyahut da bir sonraki en artı birinci kez defa geçtiğimizde yeni bir şeyler kataraktan bunları sizlere ulaştırmak niyetindeyim sevgili arkadaşlar. Yani bazen bir farkındalıkla bunun aslında şurada da kullanabileceği gibi bir arada saptamaları size yapacağım sevgili arkadaşlar. Şimdi onun için hemen diyorum ki aslında bu SciPy modülünün ilk etapta bunun en şu haliyle zaten bu çok iddialı bir kurs değil, onu da söyleyeyim. En temel SciPy içerisinde konunun işte ilgili kitaplığın ve işte alt direktörlerine tanıtılması, sabitler var. Aslında sabitler bir fizik kitabını aldığınızda belki de ilk birkaç sayfayı dolduran işte E sayısı, Öler sayısı veyahut da işte doğal logaritma ile ilgili işlemler veyahut da işte evrensel gravitasyon sabitinden tutun diyelektrik sabiti, manyetik sabite vesaire veyahut da işte fiillerle diyorum fizikte kullanılan birimlerle ilgili sabitlerle ilgili uzun bir sayfalar görüyorsunuz arkadaşlar. Bunları da tabi işte birbirlerine dönüştürmek olsun veyahut da o haliyle kullanmak olsun veyahut da birbirinin az katlarıyla üst katlarıyla ilgili işlemlerde constant denilen bu dizin içerisinden biz yararlanıyoruz. Optimizer diyerekten hemen içeriğini biraz sonra göreceğiniz şekilde fonksiyonların gerek minimal maksimal değerleri ya da işte türevleri veyahut da işte aldıkları değerler, polinomları vesaire bunlarla ilgili veyahut da sıfır kesişim değerleri bunları gösterecek. Sparse data dediğimiz içerisinde etkisiz elemanların ya da işte yanlış verilerin işte not available number dediğimiz türden elemanların olduğu verilerin arındırılması veyahut da bunlar üzerinde işlem yapılması. Graflar var. Aslında grafları grafiklerle ya da işte görsel sistemlerle karıştırmayın. Ben bu Rare Python söz konusu olduğunda arkadaşlar, yani nadir Python modülleri söz konusu olduğunda, bilmiyorum grafları da anlattım mı? Yani Python X ya da işte Network X diyerekten bir kitaplığı da var. Orada da aynı şekilde böyle Venn diyagramları gibi veyahut da işte bildiğimiz graflar. Tabii bunu işte modern matematikte o haliyle işte çizimler veyahut da işte network oluşturacak çizimler olarak görebilirsiniz. Uzaysal veriler var, spasyal data. Konular beklediğiniz kadar belki ayrıntılı değil. Fakat burada temel olaraktan işte bunun henüz daha nümerik değerler verilmeden önce bunların içerikleri hakkında bilgi vereceğim arkadaşlar. Belki bir derste bu bittikten sonra dersin sonuna doğru da bir sonraki dersle ilgili ajandayı sizlere belirteceğim. Aslında işte konular şunlar. Bunları da sizlere nasıl yapacağım? Bir Jupyter Notebook üzerinde sevgili arkadaşlar şu verilere örneklerle anlatacağım. Kaçıncı chunk'tan itibaren diyeyim şöyle, işte ilk chunk'tan itibaren var. Bir de hazır şu Jupyter Notebook'a geçmeden önce madem şurasını açtık sevgili arkadaşlar, burada şunu göstermiştik değil mi? Bunun üzerinde eğer siz kendiniz de hocam madem öyle kaynağı belirttiniz biz de buradan inceleyebiliriz derseniz içerisinde sevgili arkadaşlar try it yourself diyerekten kısımlar var. Bunları da tıkladığınızda size aslında şu kod sol tarafta editörde, sağ tarafta da konsolda çıktı şeklinde var. İşte bunu tıkladığınız zaman burada çıktığı görüyorsunuz. Aslında bu da bir anlamda işte kısmi playground ya da işte sand place gibi düşünebilirsin. Bunlar işte oyun havuzu diyorlar veya da kum havuzu diyorlar. Aslında interpreter olmaksızın, yani Python interpreter'ını bu web sitesinin kendisini kullanaraktan çıktıyı alıyorsunuz. Yani kod bu. Kodun karşılığındaki çıktı da şu şeklinde. Buradan bu dersleri bu şekilde değil de, yani ben burada bu editörü değil de ne yapacağım? Kendi şuradaki Jupyter Notebook üzerinde oluşturduğumuz w3schools.com wschools SciPy şu IPMB kitaplığını veyahut da bu defterini kullanacağız arkadaşlar. Şimdi peki bunun haricinde bir de biraz daha şöyle bir ne var ne yok diyerekten bir incelediğimde sevgili arkadaşlar, burada Python SciPy Tutorial Python Geeks'in içerisinde bunu da sizlerle paylaşabilirim elbette. Bunu ben ikinci ya da üçüncü derste anlatmayı düşünüyordum. Bunu da yine URL'ini vereyim ki hemen size bakarsanız, şöyle söyleyeyim, bunu da another source diyeyim. Resource. Yanlış da yazmış olabilirim. Şuradan da yararlanabilirsiniz. Tabii bu kurs bittikten sonra ikinci ya da üçüncü sırada yer alacak bu Geeks for Geeks. Yani Geeks for Geeks diyorum, yani şu Python Geeks. Dolayısıyla da şu konulara şöyle baktığınızda aslında şu reklamdan da arıtmak üzere şöyle yapayım. Evet. Bu Python Geeks'in içerisinde şöyle bir göz attığınızda aslında lineer cebir, integral alma, optimizasyon, interpolasyon, yani tamamlayıcılık, özel fonksiyonlar var. Burada ağır fonksiyonlar var. İmaj ve signal processing var ve de adi diferansiyel denklem çözümleriyle ilgili örneklerimiz var sevgili arkadaşlar. Tabi burada işte yağlama, ballama, işte SciPy şöyledir, böyle avantajları vardır falan fıstık. Bunlar ansiyomedik bilgiler. Bunları geçiyorum arkadaşlar. Bir de işte temelleri var. İşte paket installer'la pip install SciPy ya da işte conda install SciPy diyorsunuz ve SciPy modülünü import ederekten burada derse başlıyoruz arkadaşlar. Bir de siz olun. Onun yanı sıra NumPy ve Matplotlib'i bir de o envanterinin içerisine dahil edin. Ve de paketin içerisinde aslında geçmiş derslerde de anlattım ama şimdi yöntemimiz bu Geeks'i anlatmak değil. Dolayısıyla hemen bunu hızlı bir şekilde geçiyorum. Peki bu kadarla mı bitiyor örnekler? Hayır. Daha önceden de anlattığım yine bu Tutorials Point'in içerisinde SciPy'yi da hatırlatıyorum sizlere. Yani herkesten tabii bütün bu kanalı didik etmelerine beklemek anlamsız olur. Dolayısıyla da burada bir hazırlık URL de sizlere paylaşıyorum. Tabii sırada bu da var. Ben buraya sıra geldiğinde burada da inceleyeceğim sevgili arkadaşlar. Bunlardaki örnekleri de sizlere anlatacağım. Onu da şöyle göstereyim. Her seferinde yenilikler olacak arkadaşlar. Yani eski kursu incelemeyin anlamında da demiyorum ama neticede her bu yeni bir kurs serisi başladığında onun üzerinde ekstra ne var? İşte what's new dediğimiz yeni neler var? Onları da araya dahil edip ilerleyeceğiz sevgili arkadaşlar. Bir de aslında yine bu SciPy'ın topluluk sitesi var. SciPy.org diyerekten. Şunu da tıklayalım. Burada da asıl baba konular burada sevgili arkadaşlar. Diyeceksiniz hocam bunu niye ilke almadınız? Sonra sevgili arkadaşlar burada buzdağının ilk önce bir üst kısmını göstermekte fayda var. Yoksa burada mühendislik matematiğinin en böyle hırslı öğrencilerimiz, arkadaşlarımız dahi olsa kaçıp giderler. Dolayısıyla da burada korkutmak veyahut da işte cesaret kırmak istemiyoruz sevgili arkadaşlar. Ben o tür bir yapı içerisinde değilim. En zor konuları da veyahut da işte en sofistike konuları da evelallah anlatırız. Ancak şu var, işte bak şu derinlikte bu derinliğe kadar da anlatabiliriz deyip de öyle bir kendini kanıtlama içerisinde değilim. Burada en basitinden işte SciPy modülü nedir, ne işe yarar? Buradaki örneklerden sonra eğer ki hocam buradan ben şu şekilde yararlanabilirim, böyle şekilde yararlanabilirim derseniz bu org dediğimiz işte topluluk kısmına da ulaştıktan sonra orada işinize yarayacak veyahut da söz konusu işte OD ya da işte kısmi türevsel denklemler dediğimiz onlarla ilgili çözümleri de arayabilirsiniz, bulabilirsiniz sevgili arkadaşlar. Şimdi ben neredeyim, neyi anlatıyordum? Bir de bununla ilgili şu sayfada işte benim açılış sayfamda ne var? Burada post kısmında sevgili arkadaşlar şunu da görüyorsunuz herhalde. Yeni bir burada bir oylama veyahut da öyle bir anket yaptım. Bunu da işte belki arkadaşlarınız fark etmiştir. Burada da hemen şöyle yararlı olur. Hemen arkadaşlarımız yüz demişler. Zaten şöyle söyleyeyim arkadaşlar. Konuştuklarımın kelime hazinemin tamam Türkçe anlatıyorum meramım var ama söz konusu web sitesinin içerisindeki klaslar olsun, alt kitaplıklar olsun, library'ler olsun, klaslar, metotlar olsun veyahut da algoritmalar olsun. Bunların hepsinin orijinal isimleriyle yani ben onlara işte bir Türkçe isim katıp da onun isim babası olmak istemiyorum. Zaten çoğu zaman da hani Türkçeleştirme pahasına anlamsızlaştırma yani Türkçeyi Türkçe'ye tercüme etmek zorunda kalıyoruz. Burada yararlı olur. Lisan hakimiyetimize geliştirebiliriz demişsiniz. Aslında bundan tabii şu andan itibaren tabii başka arkadaşların da görüşlerini almak isterim ama aslında bir madem bu bana cesaret verdi açıkçası şu andan itibaren de hani İngilizce lisanına anahtarlama yapıp switch edip buradan da anlatabiliriz. Şunu da aslında hani beni cesaretlendiren bir oylama olaraktan görüyorum arkadaşlar. Şimdi kaç kişi yapmış, bir tane oy gelmiş ama en azından şöyle bir başlamış olabiliriz. Aslında ben şurada yoğunlaşacak diye bekliyordum. Hani bir kez denesek hocam daha sonra karar versek hani anlayabilecek miyiz diyerekten ama madem işte benim izleyicilerim, arkadaşlarım diyeyim, yani öğrencilerim demiyorum, benim arkadaşlarım, sizler bu konuya heveslisiniz ve de böyle bir özgürlüğün varsa bize de bunu anlatmak düşer sevgili arkadaşlar. Şimdi from now on I will switch English and I will describe what kind of environments am I use for presenting all this stuff, dear friends. Guys, this is a Jupyter environment. From start of this lecture, I have already prepared some notebooks here, Jupyter notebook items. Step by step, I will follow up the existing items, existing topics. I would like to say once again, welcome to my channel. My name is Hasan Zeki Alp. Since 1919, I've been presenting you modern programming languages and archaic programming languages and their relevant libraries and frameworks. So SciPy is one of them, and instead of implementing many boresome mathematical calculations, you can use SciPy module, and by means of SciPy methods and functions, it's going to be much more easier to accomplish some scientific data scientific problems or problem solving. So in order to install SciPy module, you have to use this pip installer, packet installer command, pip install SciPy or conda install SciPy. So that's gonna be better to mention the other alternative, conda install SciPy. SciPy stands for Scientific Python, you guys. SciPy. scientific Python. Just mentioning SciPy in order to saying its full name, you can reach all usable scientific Python libraries, sub-libraries, and classes, and methods, and functions. After implementing those two commands in my Scrabble in my chunk, it's already given a message. Your requirement already satisfied. That means I have already installed it previously. Just saying import SciPy, we could reach all SciPy functions and classes, and as a habit, as a good habit, whenever I install and import any libraries, afterwards I want to have an idea about its content. Just help SciPy. After implementing this command, just I will get a quick I use this. So this caused some erroneous situation, so I'd like to exclude it. And yes, just let's have a look the contents. For example, just before I set constant and constant as a crucial preliminary item for physics, mathematical or physical operations. That means, for example, gravitational constant, or dielectric constant, or Euler constant, etc. Just by using this utility, you can find an easy way to convert them one to the other one. And data sets, by means of data sets, you can reach, you can access usable data sets or prominent data sets. Differentiate means difference to make the first derivative, and fast Fourier transform and its package. Integrate for integration. Differentiation and integration is the inverse form of some mathematical operation. And interpolate, this is another item, and the other goes on like this. Okay, instead of saying its name, I'd rather give some examples, proved examples in order to give an idea about their utility, their usage. Okay, it goes on like this, and just by putting this hashtag, I will make it stop. And you can find out the current version by applying this one, double underline version. Okay, just saying this one. Okay, this is important, you guys, because if you have already utilized or improvised a code, you have find out in an environment, so it does not work properly, and you wonder whether the error condition is there. So just I advise you to check the version. Version compatibility means so much. If there is a deprecated class, deprecated method, so that may cause the result that you cannot reach properly. So just before starting all these things, you can make a check, version check, so you can be sure about that it's gonna be okay without any problems, right? And just you want to find out about the constant, for example, on the physical constants or what kind of constants, because you know, constant stands for some universal facts related with chemical engineering, electrical engineering, physics, the aerodynamics, optics, etc. So you can have a list of these constants that can be used or that can be converted from one to another. Just you can use these commands, right? So Avogadro constant, Boltzmann constant, Julian year, 365.25 days. That means 1 quarter of a day. So because of this reason, after 4 years, the February becomes 29. You know that. And Boltzmann. What else? Familiar for us. Electron volt, electrodyne, dyne, erg, epsilon 0. That means for space. Kilogram force, Newton, where is it? Horsepower, mil per hour, etc. You got it? Okay. By means of this command, print directory constants after importing this constants class. Okay. So let's try it at the very first, primitive one. For example, just I check out what is the equivalent of 1 liter in units of cubic meters, right? So 1 liter, so that's gonna be an output like this one. And let's try it for the sensitivity of pi constant. Okay, you know that from unit circle. Constant.pi. After printing this command 3.4, just I have already in my mind such digits, right? That's enough for mathematical calculations. And just I want to find out Euler constant, but just I used this letter E, but this is the this is not Euler constant, right? Because it's the epsilon 0, epsilon of the space, 0 space. So instead of giving Euler constant, this command gives epsilon 0, you guys. And just you can have much more information about constant by using help command. And okay, after importing constant, just you will get a full list of the whole list of this constant. Actually, most of them I have informed about that, but for example, zeta, iota, I have no idea about that exact. Just you can find out that this is the kilo, and kilo means 1000, 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, etc. So the huge numbers, right? And against this, the other parts of kilo and deci, deca, deci, centi, milli, and pico, just 10 to the power of minus 3, minus 2, minus 3, minus 6, minus 9, minus 11. So there goes like this. This is the upper ones, this is the very smallest ones, right? And after applying these commands, just we'll get these huge numbers and these very small numbers. 1 times 10 to the power of minus 21. Approximately, that means 0. Very, it approaches very near to 0. Okay. And once again, this is the constants for information technology, dear friends. Kilobyte, that means 1024 bytes, and megabytes, and terabyte. So there goes on, very huge numbers. You you can wonder what's the meaning of this. Actually, it's the power of 2 base. Okay, for example, we're talking about 6. That means 2 the power of 6. So 2 times 2 times 2 it's gonna be repeated as 6 times. That means for example mega. Okay, and the output will be like this: ZB, YB, PB. Okay, I have left huge numbers here, and after that, if you are interested in huge capacities, byte capacities, so there will be these figures in your service. So when we are talking about other constants, for example, gram means 0.001 kilogram. That means a 1,000th of a kilo means 1 gram. So correspondingly, metric ton, so gonna be 1,000 times of unit ton, and gram, and pound, libre, pound, ounce. This is same. Libre and pound means the same as you like, as you're seeing here. And okay, just I can give all this stuff in order to be familiar with the original names of these constants, dear friends, because according to your pollution, I can feel myself free to go on this lecture in English language. So just you can have an idea about their original English names, right? And how about angular considerations? Angle means that can be a degree, or arc minimum, arc second, or just degree is a great unit, dear guys. So instead of talking about degree, just talking about okay, this is this can be other dimensions of degree. So arc minimum, arc second, for very sensitive calculations, you can use arc sec yoda or arc second units. So as you see, 10 to the power of -6, that means millisecond, nanosecond. We're talking about nanoseconds. Just it's not the unit of a time, it's the unit of just a degree, angle. In principle, it's radian. So as I said, radian is a huge number, a huge unit. So it's a percent, or just like a minute or second, will be proper in order to make some calculations, some sensitive, crucial calculations without any erroneous results, right? And we go on with the constants for time, presenting time intervals, minute, hour, day, and always I say there is 86,400 seconds in a day. It's a habit, and there are other units for that. For example, this is Julian year. Julian year means in seconds. So in order to reach the real year itself, you have to deduce year and month, day, minute, etc., all the way to reach the seconds, right? And Julian year. Length, it's a measure of distance that can be this is the meters is the principal unit. So instead of using meter, you could prefer to express it in inch, feet, yard, and mile. And it's square units, not only length, and it can be area, and also it can be spatial measure of length between spatial objects. For example, we're talking about light years, so that means instead of saying it such and such figure, just we say that this planet is far from here, far from Earth, as such and such year, light year, okay? And pressure also, atmospheric pressure bar torricelle, millimeter H, millimeter just I cannot remember, just give me a sec, please. It's in Turkish name Civa, just excuse my Turkish. Okay, thank you. It's used in thermometers, as you know. And area, just by considering the square meter as principle, the first unit, and you can change hectare, or acre, and this command will automatically will give a result of hectare, okay? And volume, liters, gallon, fluid ounce, barrel, and BBL, I don't know this one. That means if you have a figure related with a known unit, so you can change it by using these commands in order to get the locally used ones. For example, gallon in US, or gallon imperial. This is, stands for Great Britain usage, as you guess. And speed, kilometer per hour, and the base is meters per second. That means for each obtaining the other units, you can use, for example, this one, Mach, mil per hour, or kilometer per hour. Just you can use this command instead of multiplying it manually in the most primitive way, okay? Just considering this one, and you would like to find out its kilometer per hour unit, so you can use this one, okay? And temperature also, Celsius, Fahrenheit, or other Römer, as far as I remember, Römer, Celsius and Fahrenheit. You can exchange one of them to others by using a specific constant. So instead of using that, simply use 0 Celsius or degree Fahrenheit. So it's gonna give a result, the correct result, without you calculate manually at each time. Energy, electron volt, calorie, erg, British thermal unit, and other stuff. Whenever you need to convert one thing to another, you can use once again constant and constant dot ev, electron volt. And let me make it a bit quicker. Power, horsepower, it's up to you to use it HP or horsepower in a full long form. It's gonna give the same result. That means horsepower, watt, kilogram dot meters per second, gonna give the watt unit, power unit. And force, another way for physical calculations, dyne, and pound force, or liber force, and kilogram force. These are all force units. And okay, let's make a calculation right now. So we use SciPy.optimize subclass, submodule, and we prefer to use root method, okay, root class. And also we are gonna use cosine function, so we have to import it from math library. Just don't worry about their content, as long as you use the updated version of this Jupyter notebook, you guys. it's gonna make an easier way to use all these libraries. What I'm saying, just as you remember when I shown you previously, I mean this one, Anaconda portal. By means of Anaconda portal, we can create some this in live broadcasting. Those things happen, you guys. I tried 2 times by clicking this one. It didn't give the result. What I'm saying, if you have already installed the very newest version, okay, very newest version, so there is no need to install it by using pip command each time, anytime. So it always give you already install it. That means this Jupyter notebook is saying me that don't worry about that. I've already prepared all the relevant environment for you to use it. Okay, just by using this root method, I will describe you what is root, a class or function or what else, just without considering it, just focus on this user-defined function, please. Okay, equation x means you will provide this x argument afterwards, after describing all this definition, and whenever you want to use equation function, you will get the result. So let's define our function as y equals x plus cosine x, right? And I'd like to find out the root of this function, function y, by using the value to x variable as 0, right? And just I use this root function, right? But I have to indicate what kind of definition, what kind of function I will use for that. Okay, I've already described it here. Just only one command for returning back this equation, right? And I have to give an initial value for that. I say 0. That means this root function does its job and gives a result for the left side of my command, my root. So what is rest is to print out my root.x. So it gives this number, minus 0.73. What's the meaning of this? Actually, I have used this function, this polynomial, and just asked SciPy to find out the root of this function. But of course, I have to give a value for the initial value for x, and after this comma, I give this initial value for x, and from right hand side, as you know, is assigned to left hand side as my root. Okay, what is rest? To print out the value of my root, so it gives an result of like this. Just some questions may arise right here. Teacher, it gives a number, floating number, probably high resoluted one, but it gives some rectangles, so parentheses. What's the meaning of this? In fact, when I made it run like this, so it gives such an error, that's a headache. It says that I have already provided you the result, but please keep in mind that this is deprecated since NumPy 1.25 version. So instead of doing this, you can use it, ensure it, by indicating its index position. Others saying it's a perfect place. So just I wanted to check it once again. So instead of using like this, and just I made an assignment, and by saying this one, okay, this encouraged me to find out much more about this figure, right? So after giving the index as 0, that means you will you can give me as far as you find out as result. So 0 means the first place, okay, just like this, okay, as in your array, and it gives me in full detail. Okay, it says that this is a float 24 number, and this is the exact value. But as you can notice that it's a float 24. This is the default value there, guys, because my resources, my hardware resources, is at the Acme level. I'm talking about Ryzen with 24 bits capability. So it gives this, and just try to find out much more about that root by using this intelligent indexing, yeah, as you remember, right? Okay. And okay, that gives an error. That means do not go like that. Okay, I've already received a message, and after that I use it this way. Okay, just like that, importing routing and cosine function, and this is my y equals to this function as result. This is user defined function, right? And by using this function as a tool to solve my function here, and simply I use print method in order to get much more detailed information about my root. Okay, and it gives this solution converts success to root. That means, okay, I can provide you a result, okay, status, and function this one, and this is the exact value. It's scientific representation, as you see, you guys, and that means the same as like this. Okay, okay, it's the same. Okay, this is ordinary presentation in decimal form, okay, and this is scientific form, okay, okay. And other trivia, if you are interested, and you can find out what's the meaning of all this, but I don't want to spend any time rather than telling you much more usable, proper things. So we can find out, we can wonder about my root. What's the type of this one? For example, type my root. Actually, we have already received the solution, but just we are very so ambitious to find out other trivia. So type my root. It gives optimized results. So that means that I've already used this optimized result utility in order to provide you this number, okay? This number, this all stuff. Okay, just let's change another example. So let's minimize the function of this polynomial, okay? So we're gonna use minimize function. Minimize means please calculate me the minimum of this function. Okay, minimize. So I have to declare this function, this polynomial, of course. Otherwise, who knows about who I want to make it solved, right? The equation x will take x parameter from outside. Okay, it's going to return this polynomial. Actually, that means this stands for and x to the power of 2 plus 2 times x. Okay. So what is request, what is needed is to calculate minimum of this function, right? Okay. So we can use minimize function by giving this equation. Okay. Just focus on this enter parenthesis, please. we have to indicate the user-defined function, right, equation, and this is the initial value, right, 0, and it's going to ask me what kind of method do you want to use for solving this minimization function, right? I prefer BFGS. Let's consider it a way to find out a method, an algorithm to find out this minimize function. Okay, almost all is ready, and I can use this the result as to assign it to my main variable. So I simply make it run by printing its value. So it gives these numbers. Okay. So let's focus on this way. That's the best way to find out what's going on about using this minimize function, or in general manners using SciPy. You guys just gives me whole details instead of simply saying that the result is this one. So this will guide us to go much more deeper inside what we are calculating, right? For example, that means all the other stuff. Okay. And this is another topic. This is a new topic. What is sparse data? Okay, at the very beginning, what I told you, we can make it easier by using SciPy utility, right? So within the context of SciPy library, just we have to entangle with some sparse data. So you will ask right away, what means sparse data, teacher? What means sparse data? Sparse data means there have been some data within that sparse data, mostly unused elements. Actually, this is the gentle way to express the not available numbers. Okay, for example, some data sets or some data may contain unused or unavailable elements. For example, 0 elements or not available number elements. Thus, that cannot carry any information, any usable information, any tangible information. So instead of using this sparse data, we'd like to focus on the unused elements in order to filtrate them, or in order to obtain much more tangible things, right? So you get an idea about sparse data. Sparse data includes some unused elements inside them. Well, what are unused elements? These 0 components, 0 elements, right? 0 items. So this is the reality, you guys. In a perfect world, there have been some erroneous data components or empty, unused elements. It's the way to tangle with. So by means of some philosophic approaches, we can eliminate these things. For example, let's have such a sparse data, right, in list form, list consideration. How to work with sparse data? Actually, SciPy, by means of SciPy sparse, we can deal with, or we can entangle with sparse data features. So CSC, that means compressed sparse column. What it stands for efficient arithmetic fast column slicing. That can be a method to eliminate that, or CSR, compressed sparse row. Just consider it. There have been a data set. It may contain columns and rows, so it may contain some sparsely populated data. I mean like zeros. So by considering this criteria, you can focus on arithmetic calculations by selecting, by preferring one of them, CSC or CSR. Okay, don't worry about that. I will give an idea. I will give an example about them, about both of them. We'd like to create a CSR matrix from an array. This is the synthetically created array, just like that, just like this one, okay, including some unused elements, sparsely populated, sparsely distributed data, right? And by considering this an object, so I'd like to find out, I'd like to use array method over this synthetically created array, okay? But of course I'd like to use this variable, this content of variable as object, as an argument of CSR matrix. Okay, CSR matrix function works for us in order to find out this one, okay, compressed sparse row. So as a result, it will give such three values. Okay, this is the coordinates. 0 stands for the row first, row 0. That means the very first row, and it's repeated 3 times. So that means there is only one row, and we're talking about this one CSR, right? So just this is the first one, 1, 1, 0, 2. Therefore, by eliminating this 0 and all this stuff, we obtain 1, 1, and 2. Okay, this 1, 1, and 2. And once again, we're talking about, we're implementing SciPy, so it easily is willingly give this expression, descriptive expression, and it says that you're using data type integer 64, and by considering this synthetically created array, we reach this condensed array, right? Okay. This is one method to use it, to eliminate it, so as to get the pure numeric values, right? And CSR matrix we have already used. And this one, what else can we do in order to get a proper data? This one, without 0 items, we could prefer to store it in a variable. So in order to do that, we use CSR matrix once again, but in this time just we use this one as a method, and this is the data, and we use data method in order to get the contents of this one. Maybe you could say that, so teacher, actually we have already found this one, but this is in matrix form, CSR matrix form, you guys. So in order to reach each elements of every element of this matrix, you have to use this method, and it's gonna give the result this one. Okay, just when you solve that, there is some values, but they are not in a regular form, or they are not in a contents form, or list form, array form. So this is gonna give the information as a array form. And just let's try another one. I'd like to find out non-zero elements, for example here, non-zero elements. Just I may hear your objections. For what purpose, teacher, will we use all these methods? Okay, that's understandable to find out without zeros, without null values. But what's the mentality? What's the logic to count non-zero elements, zero elements? So okay, we count non-zero elements, or information carrying elements, non-zero elements. So 1 and 2. Okay, we forgot this one. 1, 2, and 3. just consider this 3 times 3, that means 9 elements, but over 9 elements we have only the 3 elements that carries logic information or countable information. Okay, in order to get non-zero elements, the number of non-zero elements, we use count underline non-zero. Okay, so the result is simply printed here. What have we used? What we have used? NumPy and CSR matrix. We synthetically create this data collection, and we use array method over it, and we get this object, and by using this object over CSR matrix, we get some data, and we use this one. Just hold on, please. Alo. Tamam da yayındayım dedim ve de kapıya bırakın dedim İlkay'ı. Kusura bakmayın arkadaşlar ya. Sorry about the interruption. So, where we left. Okay, just to eliminate the zero elements, and we'd like to count on. We'd like to find out non-zero count. Okay, and method is already here. Count non-zero. What stands for? What's the benefit of this? Just to get an idea about the value carrying components, right? Value carrying elements. So instead of considering 3 times 3, 9 elements, just we use count non-zero. So it's going to give this result, this simple result, 3. So just what we have done so far, removing 0 entries or 0 components, we would like to get a matrix. We can get a matrix as eliminate zeros method. So we use the same data collection once again. So CSR matrix just as a function and eliminate zeros. This works for us. Just look what how come it can be so simple, you guys. Just consider that this can be a huge volume to matrix, for example, and you will scan it and you will do one by one or manually in a boresome way. So instead of doing that, you can use eliminate zeros, and after printing this math result, you will get this one. This is the 1, 2, and 3. Okay, by duplicating, eliminating duplicates, you can use once again all this the same data collection. What can we do right now? By adding them, we reach duplicate elements, right? For example, after making this object, okay, why I'm saying object, this is the data set, okay, artificial data set. So we use this data as a object of, as a parameter of this array method, and at the right hand side this is already created as object, array object. So I use this array object by using CSR matrix. CSR is a method or function. So after implementing this line at the chunk, at this chunk, we use math object. So over math object we use some duplicates, and as a result we use math in order to print out this value. Once again, I would like to mention this is a description what it's already done after using this one. So it's self-descriptive. I don't want to say anything about that. Okay, and we'd like to exchange the data from CSR mode, CSR form to CSS by using what? By using which method? By using this method, okay, to CSC. Why do I need such a conversion method to CSC method? Just as I said at the previous lines here, two methods, CSC or CSR method, we can use for efficient arithmetic, efficient slicing, or to accelerate the operations for larger volume to data sets or data matrices there, guys. So in some cases we need to change it from CSR to CSC. So how can we use it? Just using the same pattern, we obtain array variable, array object, okay, and then and I use this array as the parameter of CSR matrix. Okay, this is let's describe the translation of this command. Just as I indicated, this part will result an object, okay, and by using this object over to CSC method. So it's gonna give another object, but determined object, new array. Okay, and let's make it run, make it printed by using this print method. Okay. Just I'd like to focus your mind here. This is completely different from the previous one, right? As you remember, as you recall it, 0 and 1 and 0, 0, 0. 0 columns you have already seen as the descriptive coordinates, right? But in this case, after this conversion or CSC to by apply using this command, you will get these coordinates. So it's up to you guys. Whenever you see that, okay, I will prefer this kind of consideration over this population, this data. So you can use CSR or CSC. Okay, it's your option. It's your selection. Okay. And after describing the two CSC, what else? Okay, SciPy graphs. As I indicated at the very first, graph does not mean graphics or visual representation. This is a topic in modern mathematics or modern graph theory. So as far as I remember, you guys, as rare Python, maybe I have already told something about this graph criteria, graph concept. Maybe network X. The library name is network X. Just I would like to indicate here. Network X. Okay. Surprisingly, that those will give the same visual effect, you guys. It's surprising. Actually, it's not surprising for me, but just maybe you have not encountered with network X previously, so you will say that, teachers, we can do so much things by using this facility, this graph function, right? Okay, graphs are essentially data structure. Just I'd like to say some philosophical considerations about them. We are talking about the scripts, the lines, the algorithms, you guys, but mostly we see it, we consider it as a synthetically or imaginary or a toy, but in fact all things in our nature, in our environment, gives different aspects to comprehend them. For example, just we can see a class of male students, a class of female students, and some of them knows English, some of them knows English and French, etc. So in order to make a modeling of them, instead of saying it by means of a script or by means of a formula, a function, a transfer function, just we can describe it by figures or by blocks, or its name is Venn diagrams or graphs. So simply saying in large words that graph tells us much more by considering the girl's visual effects, right? So these graphs, when the concern is graph topic, we can use SciPy sparse.cs graph method or subclass. Why are we using this for data structures? Okay, in order to make much more comprehensive implementations, we use SciPy sparse CS graph. Okay, for example, an example right now, adjacent matrix. with your with my excuses, I would like to show you some visual material, visual content at this point, you guys. Instead of reading all this, I would like to show you much more okay. Let's consider this figure, right? And what can we say about this figure? This is an example of graph. So we have hubs A, B, and 3 hubs, and just we say that there are some connections between them, and A and B are connected with the weight of 1, for example, A and B. That means A and B are connected with this coefficient, with this constant, okay? And when we see this graph, we can say that we can translate it A and C are connected with 2. That means its connection, its weight is larger than this one, for example. And just we can say the last thing about that, B and C are not connected. That means there is no tangible connection, there is no weight between them. Okay, this graph says us 3 important things. So let's try to create an adjacent matrix indicating all this one instead of using these sentences A and B, blah blah blah, and A and C. Okay, this is the facts, right? In our environment, for example, when we solve 3 hub or 3 objects with this connection weights, just instead of saying this in full sentences, we can just use adjacent matrix as a mathematical method, right? Its name is adjacency matrix, or it's in Turkish komşuluk matrisi, adjacency matrix, komşuluk matrisi veya da yakınsama matrisi. So when we look at this structure, just we can find out that in a correspondence of A and B, there is 1, A and C, okay, 2, and there is no between A and C, okay? Okay, and so there comes some connected components concept. Connected components is self-descriptive. That means connected components, what are these? These are A and B connected components. B and C are not connected components. Okay, let's focus on it's a Python script once again here. I'd like to remind once again we importing NumPy SMP from SciPy CS graph. So that means by means of CS graph sub library I can use by importing connected components in order to get it visualized, maybe get it tangible form, connected components. And here I use another library, CSI matrix, as I have already told you. So by using this synthetically created array, okay, just I'd like to say a few things about them. 3 rows, okay, row the first, row the zeroth row, first row and second row. That means 3 rows we have got. So 1 column, second column and third column. That means 3 columns, 0, 1, 2, 3 times 3, 9 elements it may contain. It contains right now, okay? But as you see, some null or unused elements or zero elements. So we are gonna interested with non-zero elements. I mean this one, this one, this one, this one. Okay. So this is created and this is assigned at the left side array. Okay, so it's ready to use it as a object, as a data by using this CSR matrix method. Okay, this is matrix. Once again, object-oriented programming rules are valid as always, and this method use this data in order to get another object. Okay, my new object, this is new array. So by using this new object as a new array, I can use this connected components method or connected components functions. Always I may use it instead of the other way, the other thing, but the result is the same. This is the source, this is the main environment, and this is the functional part. Okay, this may sometimes called as function, sometimes called as dynamic methods, sometimes called as classes, etc. But the crucial point is this one. And by using this method, this function, I reach new data, process data. How come? Just like this. Okay. Connected components over new arrays method, new arrays object, and this is the. Let's describe it. Let's paraphrase its meaning. So that means this is one-dimensional, and array this all this one, and what's the D type? Integer 33. Okay. Connected components. So this is another method, Dijkstra. That sounds Middle Eastern country language, right? Dijkstra. Okay. Dijkstra method. Just we can use Dijkstra method to find out the shortest path in a graph, one element to another. This is interesting, right? Just that can be interesting question. For example, we have got a graph including more than elements, and we'd like to find out the most logical way or the shortest path. You guys, I will give you a hint. Whenever you hear, whenever you see the shortest, the longest, the best, the quickest, the blah blah adjective and est, just you can consider that there will be a magic or as sophisticated solutions between behind it. Okay, I mean if something is the blah blah adjective is, that means there will be something that works, that will work for you, and that will give you some result instead of you work on minutes, hours, or etc. So this Dijkstra method, by using Dijkstra method in a graph, for example, in a sample graph, you can find the shortest path or shortest way, the logical way or the economical path, one element to another. How will it work? Just I will give an example for that. For example, it will take some arguments from outside, return predecessors. That means the previous heifers having ones, and indices and limit. So let's describe it by using the tangible example here. Okay. What was the method? The name of method is Dijkstra. Okay. What will it stand for? In order to find out the shortest way, or the economical way, or the most proper way. It's up to you which way you can use it, right? So NumPy, we use it as abbreviated form in ampere, and Dijkstra, this is the magic method, and of course we will use CSR matrix in order to find out a proper way to eliminate, to filtrate, infiltrate the data. Always we use SciPy, sparse, CS graph, and CS matrix. Okay, simply we use this synthetically created ones, and by using this array data, array object over CSR matrix, we get new array, and simply we use this just informal way. Just we could prefer in order to find out this one, for example, my result, just with an extra line, what I mean here, and for example, print my result. Okay. You got it? Instead of saying this one in two separate lines, we can use this one. That means from the inner part, we use new R. Okay, this one. Let me exclude by doing this one. Okay. Okay. New R, new array. I use this one as a result of CSR matrix, and return predecessor. What we have seen here, it said that there's gonna be such an option here, so that could be boolean, true or false. So we prefer it true, and in this is 0. In this 0. So after printing this object, calculated object, we get this one, right? Okay. And and another method or another way. What is its purpose? Floyd-Warshall. Floyd-Warshall. Just you can consider it that okay, teacher. Just we can use this Dijkstra, but maybe I can find out, I can design another way to find the shortest way. Okay, it's up to you, you guys. And as you see here, after this, the first example, some other people just focused on focused on this consideration, and found another ways, another options, another solution ways to find out the shortest path. For example, this is Floyd-Warshall. We mentioned it with respect, with esteem, by the way, and let's have an example by using Floyd-Warshall. Simply we import Floyd-Warshall method, and this is the API. As you see, by means of its capability, we can use new array, and by using this option as true, we obtain this the shortest way. Okay, just when we consider more clearly, we see that this is the array, okay, and after considering this Floyd-Warshall algorithm, we get this one. Okay. So is this the last? No. There are other methods. As you see, most people like Bellman, Ford, or this gentleman, Floyd-Warshall, many people worked on this optimizing algorithms, just I can say, and in this way Bellman-Ford method can be used to find out the shortest way, shortest path between all pairs of elements. This sounds some kind in generalized form. For example, just we have said that the shortest way, and by using this one, by mentioning its method after, of course, importing its content as API, we get this one, more clear and more descriptive. What is meaning? This is the array, the shortest path between all pairs of elements. Okay, Just there is no need to mention that in this NumPy array that corresponds to a physical representation. In fact, just I have mentioned at the very beginning of this topic, this lesson, this class, and instead of mentioning all this imaginary part, just we mention it or we correlate it with this array. Of course, always we talking about, we are saying that where is that, this structure, this graph, or similar to this graph, and thus instead of picturing this graph, we're talking about NumPy language, NumPy syntax, right? Okay, understood, right? This is the simple way to teach the basics. Okay, Floyd Marshall and Bellman-Ford, also Bellman-Ford, by using the Bellman-Ford method algorithm optimizing, it results these figures, right? Depth first order. There is another method, first traversal from a node. Of course, in a graph picture, there will be some nodes, some connections, and maybe some hierarchical subnodes, etc., or upper levels. So, according to the sophistication of the matter we are focusing on, there could be very first very simple form or very hierarchical forms as a graph example. Once again, I repeat it, we're talking about a visual effect, visual components, but in real feature, no, in real world, that corresponds to some facts. Facts number one, blah, blah, blah, blah. Facts number two, between the nodes such and such and such, there will be a weight of such. And number three, absolutely there will not be a connection between these nodes, X, Y, Z, like this. And as a result, we'd like to find out depth first traversal. So what will be used for that in order to find out that? Depth first order. That self-descriptive, okay? You understand? Depth first order. So what for what purpose can we use it? As I said, in the very first simplest form, anything can be described by visual aspect. Okay, but if the hierarchy means very complex or comprehended form, instead of focusing on specific nodes, just we pray to find out a method for that. Okay, our praying gives a result. Depth first order will give the result what we're asking. Of course, let's say spend a few words about arguments. The graph, of course, absolutely is necessary, and in order to traverse a graph from the very first one to the last node, last element, we have to traverse, and where will be the starting point for that starting element? So we have to indicate a starting element, and that's it. This is it. This is all we need to indicate for using this depth first order method, right? So just we have to remember adjacency matrix. We have given previously. Okay, so by using that adjacency matrix, we will traverse graph depth first. How? Just like this one. Okay, please consider this 4 rows and 4 columns. That means 4 times 4 are 16 elements. Okay, this array, I'm talking about this array, and it is up to you to describe or to visualize it by using the graph components, visual components, right? It will improve your imagination. This is your task. Okay, I'm talking about A, B, C, D, right? And here, after creating this array as an object, and I use CSR matrix over this object, and I will get another object as a result of OOP rules, and it's called as new array, new R. And I will use this the magic depth first order method for the first time, right? How come can I use it if I have already imported by using this line of code? We are free to use it anytime, anywhere, right? Depth first order and a new array, and this is the default parameter. And after applying this print method, we obtain this one, right? Okay. Okay, one suggestion here, instead of trying to comprehend its mathematical or numerical meaning, just make a consideration in your mind in spatial manner, what I'm saying, and make an imaginary part of imaginary copy of this data collection in your mind as a graph. Okay. If you could manage this, all would be much more tangible, or would be more logical, more descriptive in your mind, you guys. Otherwise, these are all simple figures, okay? And it may mean whole or nothing for the ones that depends on the person that may installed an imaginary view in their minds. Understand? Okay. Another topic, breadth first order. This is another method. What is it for? What can be for which way we can use it? From a node, a breadth first. Traversal. So we will need graph and for starting element, the very first starting element. So we will need adjacency matrix, of course. I forgot to mention it. Our adjacency matrix is this. Adjacency matrix just gives a mathematical equivalent of visual aspect of the events there, guys. This is the mathematical formula of that imaginary or intangible okay. Why I hesitate this? Because if the concern is a physical way or physical aspect, physical event, I would be very happy to find out, to describe it willingly, easily. But if the concern is some kind of intangible things or some phrases so as to be converted to mathematical array, that will raise the difficulty of you guys. You see what I'm struggling to find the proper way to describe what I'm telling you, right? And this is CSR matrix, and we get another new R variable here, and breadth first order. This will work for us, and will get a result of these figures. Okay, this is another topic, triangulation. At this point, I'd like to focus on your mind. Maybe I have already described the Delaunay triangulation, Delaunay library. Just I will check it. Oh, I'm not talking about this. I'm talking about this Delaunay. Sure. Here. What's it for? I can hear your voices. What's it for? Is what's it for? It's important in graph theory, you guys. Delaunay, and instead of focusing giving to this Delaunay library, just I will give an idea about the Delaunay triangulation. Yani, I mean to generate triangles by using some comprehensive data. More descriptive way, triangulation means creating creating surfaces, triangle surfaces. Okay, let's speak the code instead of our description, you guys, as some guru says that don't try to describe it. Just let the code, let the algorithm says it by itself, right? This is more or less the same meaning. This is what I remember. Okay, the following points I will try a triangulation, and by means of this Delaunay method, I will apply another simplest sub method once again. I would like to find out once again Delaunay is a separate library, Python library, in order to create a triangulation and graph theory. It's important, but here we logically, here we locally will use it for other in other form. Okay. Here I will import SciPy Spatial, import Delaunay. Delaunay will work for us. Delaunay is an API. And I will use it for virtualization. Okay, visualization. Sorry, and this is the our matrix, data matrix that corresponds to a physical, meaningful graph. And by using these points, data collection, I will use it in order to get Delaunay triangle shapes, and after obtaining these shapes, I will make it simplest method, and at the left side, at the left hand side, I will get this number, and in order to create three plots or tiny triangles, I will use tree plot, and after that I will use, of course, a scatter. Tiny plots will create the size of the triangles, and by using plt.scatter method, I will define the points, red, just like look here, red points. Actually, it's 2 plus in one canvas. There are 2 plots. One is scattered values, okay, the red balls, right, and the other one triangular sections calculated by 3 plot. But we have already used this one, and by considering this as an object in order to get simplest or slices, triangle slices, Delaunay, by using Delaunay method, and by using this method 2 times. The first 3 plus for drawing triangles, and the other one for scattered points. Okay, just we use points array, points object, and by this intelligent indexing. Okay, that stands for from 0 to the very end one, and the y component, the other component will be 0, and this is the first element. And what about the other one? The whole axis, and the one for the other coordinate. And this is for triangles. This is the points, red points. And after applying plt.show, you will get such a topological graph. Okay. It is up to you to enrich your imagination in order to use it. How come, how difficult or how comprehensive in your mind in order to trigger creative ideas in your mind. Okay. I know for different IQ levels, for different IQ level people, that's gonna trigger some ideas such as how can I use this fact, this utility in order to find such and such and such. It's up to you guys. I herewith only give an idea about its usage and its visual effect. Understand? Okay. Another topic is convex hull. Convex hull, as you can guess, is the smallest polygon that covers all over the given points. That means there are some sparsely distributed points, and we'd like to cover all these points, all these meaningful hubs, so as to create a polygon, but that could be the smallest one. So there will come a function in order to calculate the convex hull or the smallest polygon. Okay, the convex hull means this is the one. This is a descriptive thing. This is its specific name, right? So the method will be convex hull, of course, and just we'll import convex hull method, convex hull function. So our numbers, our data will be like this, and this will create a variable named points. So just we simply use this points object over convex hull function. Okay, and at the left side this is assigned as hull, and hull points will be hull simply this is smallest parts. So it's already calculated, and what else now? We have to scatter, we have to make it visualize by using scatter function, right? Points from 0 to the all the way to the end, and 0 for this axis, and the other one. Okay, let me remind once again, in order to create, in order to draw, in order to use a scatter function, we only need two values: resource value and the descriptive result value. This is independent variables, and this is dependent variables. Okay, this is independent, this is the dependent variables. According to the definition of function, this is the x parameters, this is the y equals to fx function. Okay, transfer function like this, and I have to repeat it by means of a for-in loop, you guys, and our hull points data set includes all we need here, and we will traverse over hull points by using this simplex counter. Simplex will be our counting component, counting element, and after this indentation, we repeat all these commands here, and actually just we can add this command here. That means between the for and pass commands, I will repeat all these examples, these commands, right? Sorry. And at the end of this traversing over hull points, just we get all information, and what is left in order is to show it, that one. As you see, this is the convex polygon urites, but the smallest one. Just we could make it larger one, but instead of that, all this convex polygon actually obeys all the rules, okay, all the for all the components, and this is the smallest one. Okay, just to give an idea how to use it, or how to implement it, how to enrich the result as a creative mind. Just there will be some data bundles, for example, but you don't have any idea about how large they are, or how differentiate they from each other. They don't have any idea about that. But just you consider it in your mind in one cell, and you will have another, for example, another polygon, convex polygon, right? And just you find that you want to find out if there will be an intersection between them, or if there will be any neighborhood between them. And in order to find a proper solution for this trivial or comprehensive questions, you will make it visualize in physical manner. So this convex hull will run for your for this purpose. For example, this could be one bunch of data, and there will be points, another points two could be another one, and just you will have an idea about how they are intersected each other, or how they are limitized by its functional definition. Okay. For example, separate the first one and the second one, and in one diagram, two of them could be drawn with differentiated color components, for example. In my mind, the first trigger thing would be like this. And we go on with this one, KD trees. KD trees means the nearest neighbor queries. Look here, step by step, example after each example, we are approaching the crucial topics of data sets. I mean, the nearest neighbors algorithm, or the nearest neighbor concept. So as you see, whenever you find out, whenever you learn much more methods about data structures or data sets by using SciPy's sophisticated functions or sophisticated sub-libraries, you will be much more experienced about the algorithms or methods for considering more comprehensive way, such as nearest neighboring algorithms. You understand? And KD trees will be used for that in order to create the data structure optimized these queries. Queries means inquiry steps or inquiry commands for what? For nearest neighbor concept. Here, by using KD trees, we can efficiently find out a set of points. And how can we use it? Okay, and please keep in mind, as a result of this KD tree method, and the KD, that means KD tree method will result as a object, and by using this KD object, we can make it more comprehensive data sets object. Okay, data set element. And for example, find the nearest point 1 to 1. Okay, what is needed is to import SciPy Spatial and import KD3. So KD3, we will use KD3 method, but we will need object, and the data object is like this. Data collection, a list, including some tuples, some data doublets, x, comma y, x, comma y, x, comma y, and it's named as points. So over points we use KD3 method. Okay, as a result we will need, we will reach an object KD3, smallest the lowercase KD3, right? So by using KD3 object, we use query method. Query means inquiry, to ask about itself. That means like this. In Turkish form, sorgulama, query, sorgulama. KD3 sorgulaması. Okay? And here, over KD3 object, I make a query method. I will try to use query method, and by this parameters. Actually, just you will have a look that, okay, you guys, this is the points, sparsely populated, sparsely distributed points, for example, and just we like to make it find out. You would like to find out how come this number will be in neighborhood, in neighbor query, okay, nearest neighbor. We are inquiring this one. So the result is RES result, and this is the numerical value 2.0, and numpy integer 64 and 0. Okay. Actually, maybe the next time I will give another more tangible, more comprehensive, more descriptive examples. Just I will constrain myself just giving these examples, and after completing this one, I will describe another website in English form or Turkish form according to your questionnaire results. Okay, distance metrics. There, guys, probably you will recall something when I say distance metrics. For example, Manhattan distance, Euclidean distance, cosine distance, distance, etc. Just I can hear your voice saying that you have forgotten Manhattan teacher, Manhattan distance. Okay, be patient, you guys. I understand your stubbornness, but we go one by one, right? Distance matrix. Okay, let's imagine that we have got some address, an exact location in three-dimensional or two-dimensional space, right? And we'd like to express it by using the last numbers, last figures. For example, this can be oriented, this can be described as 1, 2, or 3 dimensions, right? X, Y, or Z, like X, Y, or Z axis. Okay, but okay, the matter is to describe it, but we have sometimes need relative figures regarding instead of saying it's exact place. For example, near to blah blah, or işte exactly is far from this point, such and such kilometers or steps or blocks like that. Okay, and here there are some algorithms here. For example, Euclidean distance, cosine distance, or Manhattan distance. For example, you will describe one place by considering Manhattan blocks, and you will say that after such and such blocks, and turn right, turn left, and after such and such blocks, you will reach here, and not yet finished the 28th flight of Empire State Building, etc., etc. So you will describe it relative to some other well-known place, okay? Well-known geometrical place. So there are some distance concepts. For example, Euclidean distance. Just I can give an idea. We are talking about hypotenuse, you guys. We have got two oblique sides of a triangle, and one point is the starting point, and the other point is the distant point, and other saying the other point of your triangle. So if we find out Euclidean or hypotenuse of that triangle, right triangle, we will find out Euclidean distance. Some geometric Euclidean theory, you know that. So Euclidean function will do that instead of us. And the first point, the first origination point, just let's say this one, 1.0, 1 stands for x, 0 stands for y axis, the oblique axis, this is the horizontal axis, this is the vertical axis, and the other point will be here. Just let's say this is the initial point or starting point. This is the target or the final point that where we have to reach out. Okay. So simply we use Euclidean and with arguments, these parameters, palm first, the palm second. Just you can imagine that after the iceberg of under the iceberg of this function stands for Euclidean theory. Şöyle söyleyeyim. Let me say hype diye kısaltayım şöyle. Let's abbreviate like this. Hype. X to the power of 2 plus y to the power of 2 to be square rooted. Okay. Understand? Iceberg or API, what I mean is like this one, hype. So by using Euclidean, so it's calculated according to this equation, Euclidean equation, and whereas stands for result, simply we print out as result. Hoppala. Anyway, okay, you understand square root, SQR2. Okay, it's understood, I think. Instead of calculating this in primitive way, you simply use Euclidean and by indicating the first initial point and the target, and Euclidean method, Euclidean function will calculate it as Euclidean distance, and you will make it run. You can print it like this one. Okay, result non-Python. Okay. Another one, a city block distance, but this is less known as city block. This is much more known as Manhattan distance. Just consider it the New York City and Manhattan Island, and in order to describe one place, exact place, you have to indicate boulevards and roads and streets and flat, of course, maybe the name of block you will indicate. And is the distance to compute 4 degrees of moment. Actually 4 stands for one dimensional, the other oblique dimensional, and the third dimensional, and maybe you can describe it by mouse keys, up and down, left and right, or not diagonally. Diagonally means, of course, this Euclidean. So you cannot go through blocks in Manhattan Street, Manhattan Island. You only use up and down, right and left commands, right? So city block distance. Instead of saying Manhattan or other proper name, we use city block. This is the function that stands for Manhattan distance. We are calculating Manhattan distance. For example, let me enrich the context with Manhattan distance. Manhattan distance. Okay. For example, from starting this point to this point, if we want to use Euclidean, we will have to indicate, we will have to calculate Euclidean hypotenuse of this one. But instead of going there, but if we want to use Manhattan or city block addressing, we will go, and this is the shortest way. For example, this is the Manhattan map part. This is the starting point, and this is the final target point. And by using Manhattan or mid down city blocks point, we go this one. But look, actually, maybe you will see that teacher, you said no diagonal ways, but just left and right, left and right, left and right. Okay, this is some way. This is another way. Okay, city block distance. Okay, this is the starting point, and this is the final point. And by using city block method, we will get the result. Of course, this is going to be a little bit different from the Euclidean distance, of course, but this is more physical, more practical, more realistic way. Instead of flying the blocks, this is much more realistic, right? City blocks. This is the coordinates of the first starting point. This is the coordinate of second one. Okay, just I will make a remark with these distances, with these distance calculating functions. This will be used, this probably will be used in data science, artificial intelligence algorithms. So we have to brush out the usage of city block functions or Euclidean distance functions. Once again, this will have a this will give an advantage for us by reminding them. Cosine distance. Let's consider that we have got 2 points, and we calculate cosine angle between them, and cosine distance will give an idea about their points. Normally in marine applications, these between these 2 points, cosine angle calculation will be used, as far as I remember, you guys. And let's give an example for them. This is the starting point for an horizon, for example, and this another point for over the horizon, and by using this two starting and final point, by means of using cosine, we'll get an idea about the distance between them. Okay, cosine, by using cosine function. Maybe you have wondered about what's the type of this cosine, for example. Okay, just when we inquire about the cosine, of course we get that a function. Cosine is a function. Cosine, just like city block, just like Euclidean, right? Cosine function, and insistently I try to find out cosine p first, comma p second. Maybe that's gonna make nervous, but this is my ambition. I'd like to find out what the hell it is. For example, excuse my French, cosine, and it gives the bits and pieces. Float 24, right? Okay. Float 24. That means it's you have at last you got a numeric value. Okay, actually, this is the numeric value, and float 64. As far as it could be described with a floating point, 64 bits. Okay, and of course, if the concern is Boolean variables, Boolean facts, there will be, of course, some distance concept. Not only comparing 2 bits, true or false. Of course, when you compare true or false, 1 or 0, of course there will be 180 degrees of opposition between them. But we're talking about bit sequences, serials of bits, and just would like to find out how similar the sequence 1 from the other one sequence 2, or how what's the distance between these bits, right? So shortly we're talking about having distance. So let me say one thing, that not only it may be different, it may be so similar, and that could be only 1 or 2 bit different. That means maybe this could be error rate, for example, you guys. That remind me of my university years and number theory and communication theory. We could calculate the possible error rates, for example, bit error rates. So we had to use Hamming code. So after using Hamming inquiry, if we use a proper result, we could say that okay, this method is so reliable, and you can rely on this result. So after passing this bit environment, our two results, starting point and starting sequence and final sequence, could be used to reliably. Okay, Hamming distance gives an idea about their being different degree. Okay, we're talking about truths and false Boolean variables. Okay, and let's say by saying Hamming, import Hamming will work for us. Hamming function or Hamming distance calculating function, shortly Hamming, and this is the first tuple, true, false, true, and the other tuple data structure, false, true, true. So what is required from us is to find out Hamming distance or Hamming differentiation or Hamming reliability. So when we calculate, when we use Hamming code, Hamming function for this, and result will be like this. This is more than half of it, and it's up to you to interpret it. To interpret its interpretation is left to you, you guys. And one more thing, if we could very similar to the first one, for example, and if this result approaches to 90, for example 99, and we could say that there will not be any Hamming distance between P1 and between P1 and 2. What I'm saying, let me repeat this one. Let's say the final or the other distance or Boolean expression will be like this. And actually we're not informed about fallacy, right? This is the transmitted one, for example. This is the receipt one. Please consider it only Boolean. Instead of Boolean expression in electronic meaning, it means plus 5 volt in order to express true or false about 0 value voltage, right? And this is the bit stream sent, and this is the another bit stream translated to Boolean expression like this. And let's find out this distance. Okay, and the distance is decremented. Okay, others saying the reality, the fact is approached to 90. Okay, let me okay, what I'm saying just like this, it's about 90. Of course, you could object this. Okay, teacher, you only changed this one, but maybe how come do you know that this is not so important? Maybe this is a crucial bit, and this is gonna scrub all the things, all the value. Okay, you're right, but just this is the example. This is the descriptive example. We're talking about distance, but 1 minus result, 1 minus Hamming code means the reliability in some way, right? Okay. Yani in Turkish olmayana ergi metodu. What I'm talking. Okay, SciPy MATLAB arrays, just as in MATLAB utility, we can talk about, we can make some examples, we can make some operations, MATLAB as well. So just we can say that interoperability with MATLAB is possible as well. So let me give an example. For example, let me say by using arrange method in NumPy, that means from 0 to 9, 0 is included, 10 is excluded, so we arrange, arrive variable. So we save math IO burada just here SciPy from SciPy import. By importing this method, I use IO function. Just you can see at the very beginning of this lecture, you guys. Maybe. Anyway, it's deactivated. Okay, what we left here. Okay, MATLAB format. The task is how to import data by using our functions, loadMap function, in order to get MATLAB format. So we use IO function by means of this SciPy library, and this is our data collection, and I obtain an array object, and I use this array object, and over it I use math method, and by using this interpolation WAC variable would be array. Okay, I already recall it at this point. So the method here used is save math. This for exportation. That means by using save math you will create a file like this, and it could be reached outside, or it could be used by outside people. So in order to reach it or import it, how to use it, the opposite of save math, I mean load math will work for that, array math. That means if you change this another way, so you will reach it by changing this one. Okay, array first, array second, for example. So this will recall, or this will collect data in MATLAB format. Okay, just when we use print method in order to visualize it, all this data, this will get this results. Okay. Okay. You not necessarily need MATLAB format, but in your mind, and one corner of your mind, in one place, you will learn this one. Okay, sure, save math and load math, and whenever you need such kind of MATLAB format presentation, you can use easily this one. Okay, understood? Yes. Here from MATLAB data only this is a hint, and this is important warning, I think. Use variable name VAC to display only the array format it's saying. Just like that here, instead of giving this one, okay, that is described as instead of saying this one, you simply say it, my data, and this specific part, WAC part. So WAC part is like this. Instead of seeing so many trivia, just you will focus on this data, right? This is another utility. Just is saying that please use VEC to display it simply or more clearly, more eye-catching way. Okay, we're talking about here, of course, one-dimensional arrays, and argument. In order to resolve this, we can pass additional argument. Squeeze me true. Okay, squeeze me or flatten me true. Squeeze me. It sounds ridiculous. I think. Instead of using this, you remember flattening is a method in order to make one two-dimensional array. In order to make it one-dimensional, you make it flatten tire, like flattened tire, patlamış lastik, patlamış lastik in Turkish. So in order to convert two-dimensional array to one-dimensional, you have to mention it as argument, additional argument, squeeze me true. As long as it's true, it is gonna resolve it to make a one-dimensional array. Okay. And example, okay, for importation we use as we have described load math or save math. So we know the name array MATLAB, and by after applying load math function, and we use it squeeze me, this is true. Just after printing this, you will see that maybe you make objection. You can object to this, teacher. This is the same with the previous one, but you have not noticed the dimension of this data structure, you guys. As I mentioned earlier, previous times, double parenthesis means the second order or the second two-dimensional, okay, second dimensional, two-dimensional array. So by using this one, please squeeze it for me, squeeze it for me, or squeeze me. You simply make it one-dimensional array, 1D array, right? Of course, numeric values may not be changed. The same will be left same, but we make it a one-dimensional array. This is the key point you have to keep in mind, you guys. Okay, I don't have any idea what time is it right now, so I know your attraction brain activities may be so tired right now. Let me suggest you something. This item could be described by means of another lecture, right? So next lesson we'll start right here. I'm saying evet, burada Türkçe konuşalım. Arkadaşlarımız bir şeyler sormuşlar. SciPy kitaplığı genel olarak hangi projelerde? Şöyle, projeden ziyade SciPy kitaplığı, Barut, şöyle söyleyeyim. Veri biliminde, Data Science dediğimiz veri biliminde SciPy kitaplığı belki de en az başvurulanlardan, fakat başvurulduğunda da yaptığı işler bakımından da çok böyle insanın veyahut da işte takım çalışması şeklinde çalışırken insanların işini kolaylaştıran bir kitaplık. Şimdi şöyle örnek vereyim. SciPy kitaplığından mesela tanımlaması yapılmış bir fonksiyonun türevini hemen aldırabilirsiniz. Türev ne işe yarıyordu? Türevini sıfırladıktan sonra o fonksiyonun aldığı maksimum minimum değerlere siz hesaplayabilirsiniz. Şöyle söyleyeyim, bir dataset var. Datasetin satır sayısı var. İşte datasetin işte 10 binlerce bir satır sayısı var ve de kategorik verilere, nümerik verilere, alfanümerik verilere, hatta boolean verileri de içeren mesela işte 20 tane sütun sayısı var. Ama sütunların her birisindeki verilerin de kendi içerisinde işte mesela 10 binlik bir veri diyelim. İşte 10 binlik veri içerisinde de birbiriyle korele olabilecek veyahut da işleme hiç sokulması gerekmeyen, sokulması durumunda boşu boşuna bizim zamanımıza işlemcinin çekirdeğinin enerjisini alacak kategorik veriler var. Onları üzerinde aritmetik işlemler yapmak için. Mesela burada ne dedik? Bir tane işte non-zero elemanların sayısını veyahut da non-zero elemanları seçen bir yer gösterdik mesela. Böyle bir örneğimiz vardı değil mi? Şöyle söyleyeyim. Hammali kısmına barut SciPy kitaplığına yaptırıyoruz. Şöyle mühendislikte okuyan arkadaşlarımız bilirler. Ya hocam işte çok karmaşık bir takım işte ODE var, ordinary differential equation'lar var. Bunları nasıl yapacağız? Halbuki yani bu denkleme parametrelerini verdiğinizde ve de çözme algoritmasını, çözme yöntemini belirttiğinizde size bunun hemen çözümünü gerçekleştirecek. Yani proje olaraktan şöyle söyleyeyim. Yönteminizde veya da işte projenin içerisinde yoğun matematik gerekiyor. Fakat bunu da ya ben bunu nasıl yaptırırım? Burada işte Lagrange denklemleri kullanılacak. Yok burada işte pek çok hani sesle mesela ses kitaplıkları ile işte çalışma yaparken ses kitaplıkları veya da işte sesler transducer'dan geçirilerekten elektriksel sinyallere dönüştürülüp de onlar da analogtan dijitale dönüştürüldüğünde bit streamler elde ediliyor ya. Bu bit streamler üzerinde acaba hangi frekans bileşenlerine içerecekler? Tabii bunlara biz neden ihtiyaç duyuyoruz? Bir A kişinin sesiyle B kişinin sesinin birbirinden farklılığı nerede alakalı arkadaşlar? A kişinin sesinin işte bir A hecesini veya da işte E hecesini söylerken kullandığı frekans bileşenleri diğerinden farklı olacaktır. Mesela ben E dediğimde farklı olacaktır. E dediğimde farklı olacaktır. Değil mi? Yani dolayısıyla da bu frekans bileşenleri dediğimiz işte o fast Fourier transformundan geçirilerekten ki fast Fourier transformu da bundan sonraki derslerimizin baba konularından bir tanesi olacak. Bununla karşılaştırma yapılacak. Veyahut da hadi sesten çıkalım, görüntüye, imaja gelelim. Bir görüntünün biliyorsunuz işte NumPy dizisi haline getiriliyor. Bir siyah beyaz görüntü. Yani onun varsayın ki işte siyah noktacıklar ışık yok ya da bilgi yok. Beyaz noktacıklar bilgi var şeklinde. İki boyutlu bir matris halinde tanımlayabiliriz. Eğer bunu renk olgusuna katmak istersek red, green, blue renk bileşenlerinden bir tanesini de işte FF ile belirteceğimiz 0'dan 255'e kadar bir sayıyı da belirtebiliriz. Bir tane daha parametre katılabilir bu görüntü dosyasına. O da krominans lüminans bilgisi olabilir. Lüminans bilgisi de aydınlık bilgisi. Aslında aydınlık bilgisinin de bizdeki tanıdığımız karşılığı görüntünün yazdırılırken transparency dediğimiz o arka tarafın ne kadar görüntülenmez olduğu veya görüntülenecek olduğu. Şöyle diyebilirim. Matematiğin içerisinde boğulduğunda çağrılacak olan kitaplıklardan bir tanesi SciPy. Dolayısıyla SciPy'nin içerisinde ben SciPy'yi kullanarak neler yapabileceğiniz konusunda eğer bir fikriniz varsa bu çok işinize yarayacaktır arkadaşlar. Hem şöyle söyleyeyim imaj geliştirmede, iyileştirmede hem ses tanımada daha sonra görüntülerin, imajların belirli bir kanvas üzerinde ilişkilendirilip onların birbirleriyle olan ilişkilerinin gözlenmesinde ki bu otonom aygıtlarda hiçbirisinin üst üste gelmemesi lazım veyahut da onların böyle bir yakınlık mesafesinin bile şunun altına düşmemesi lazım gibi bir takım böyle bir restrictionların, kısıtlamaların olduğu durumlarda bu bizim çok işimize yarayacak sevgili arkadaşlar. Ben şöyle sizin işte deneyimli abiniz olarak tanıdığım bu tür metotlarla ilgili belki de doktora tezleri veyahut da işte master mezuniyet tezleri verilebilirdi. Yani bu konular matematik tarafı çok yoğunluklu olduğu için ve de bunu da işte bir kişinin işte böyle bir harcı olmayacağı için de çok inceleme, yoğun araştırma konuları oluyor sevgili arkadaşlar. Benim burada sizlere tabi matematiğe boğmak değil, bunların metotlarıyla ilgili hem terminolojiyi de anlatmak. Gemi mühendisi bir yeğenim var benim. Amca dedi, sen neden bu derslere işte İngilizce anlatmıyorsun dedi. Düşündüm orada işte ilk önce zaten ben dedi gemi mühendisi değilim dedi. Tabii marine engineer diye geçiyor. Yani denizcilik mühendisi ve de dolayısıyla da bu anlattıklarımızın da işte kendi ana dilimizin dışında da hem terminoloji hakim olma bakımından diyeyim hem de bu İngilizceyi de ilerletme bakımından birçok hata yaptığımın farkındayım. Aslında hani uzun zamandan beri böyle işte ana dili İngilizce olan birileriyle de çok seyrek karşılaşıyorum diyebilirim. Fakat en sevdiğim dillerden bir tanesidir bu İngilizce. Dolayısıyla da hem terminoloji hakim olmanız bakımından hem de kulak dolgunluğu olması bakımından bunları anlattım. Ama bu açıklamayı tabii kendi ana dilimizde belirtiyorum. Siz öğrenin. Bu dersimizde çok az konu kaldı. Bu geri kalan şuradaki işte interpolation konusundan sonra ya Geeks'i anlatacağım ya da doğrudan da onun topluluk bir sitesi olan SciPy.org'u anlatacağım sevgili arkadaşlar. Tabi daha da zorlaşacak. Daha doğrusu şöyle söyleyeyim, anlam kazanacak. Çünkü benim en sevdiğim şey kodun üzerinde nümerik değerlerin olup onun somut görselleştirilebilir. Böyle hayal edilebilmekten öte ortaya konulabilir sonuçlar vermesi. Hemen bu sonuçları gördüğümüzde zaten beynin görsellikle ilgili kısmı asıl yaratıcı kısmı biliyorsunuz. Eğer böyle görsel böyle onu hayal edilir hale gelmişse o beyin hücrelerinin o kısmı artık onu sembolleştirerekten veyahut da onunla başka beyindeki diğer kısımları da ilişkilendirerekten buradan yeni bir şeyler çağrıştırabilir. Neticede her şey elektrokimyasal veyahut da işte elektriksel pulslarla oluyor sevgili arkadaşlar. Benim de size katkım bu şekilde olacaktır. Derse burada sona erelim diyorum. Az bir nokta kaldı. Eğer ki ajandaya da siz hala İngilizce yazmak iyi olacak derseniz İngilizce anlatıma da devam edeceğim. From now on I will describe it in Turkish, in English, you guys. Just according to your inquiry, your questionnaire results, I will go on with English or not, but I think that most of the observers, most of subscribers, listeners would prefer to hear it, to listen it in English in order to be familiarized with the topics, with the lesson content. So according to your result, I will decide how come I will describe it or not. Thanks for your cooperation. Thanks for your time. Please remember to subscribe my channel and you could activate warnings, and if you like this content, you would put a like sign. Thanks beforehand. Bye bye. Take care.